But I now want to make an important point. Calling this unified theory of the large and small a theory of everything is hubristic and misleading. That's because such a theory is irrelevant to 99% of scientists. All those scientists work on a third frontier, the very complex, the things at the bottom of the picture. Insects, people, and mountains. Entities large enough compared to atoms to have layer upon layer of intricate structure, but not so large that they're crushed by gravity. Problems in biology and in environmental and human sciences remain unsolved because it's hard to elucidate their complexities, not because we don't understand physics well enough. Even an insect, with its layer upon layer of complexity, is harder to understand than a star, where intense heat and compression by gravity preclude any complex chemistry. And this picture, incidentally, is the famous flea drawn by Robert Hooke in his classic book Micrographia in the 1660s, depicting observations made with his pioneering microscope. He was Isaac Newton's least favorite FRS. The sciences are sometimes likened to a tower, the different levels of a tall building. Particle physics on the ground floor, then astrophysics, then chemistry, and so forth, all the way up to psychology and the economists in the penthouse. And there's a corresponding hierarchy of complexity, atoms, molecules, cells, organisms, and so forth. But the point I want to make is that the analogy with a building is poor. The higher level sciences dealing with complex systems aren't imperiled by an insecure base, as a building is. Each level has its own autonomous concepts and theories. For instance, to understand why flows go turbulent or why waves break, some atomic details are irrelevant. We treat the fluid as H2O and don't care about its atomic structure. And to take another example, an albatross returns predictably to its nest after wandering 10,000 miles on the Southern Ocean, but that's not the same kind of prediction as astronomers make of celestial orbits or eclipses. Everything, however complicated, breaking waves, migrating birds, tropical forests, is made of atoms. It obeys, so far as we know, the equations of quantum physics. But even if those equations could be solved, they wouldn't offer the enlightenment that scientists seek. Reductionism is true in a sense, but is seldom true in a useful sense, because each science has its own autonomous concepts and laws, which are the ones where you have explanatory power.